What's up, folks? Today we are going to start by looking at Rolle's theorem. Let f be a function that is continuous on the closed interval from a to b, is differentiable on the open interval from a to b, and has f of a equal to f of b. Then there is a number c in the open interval from a to b such that f prime of c equals 0. Let's look at a few examples of functions that satisfy these requirements. Okay, so here are 4 very rough sketches of graphs of functions, and each of them is continuous on the closed interval from a to b. They're differentiable on the open interval from a to b. What that means is that they don't have to be differentiable at the endpoints, which means the function doesn't have to be defined outside of that interval. It could be that these functions are defined even further, and they might be differentiable at the endpoints, but we don't require them to be differentiable at the endpoints, so that means that the function doesn't have to continue in either direction after those endpoints. So all of these functions are continuous on the closed interval, differentiable on the open interval, and you can see that I've at least done my best to make it clear that the function values are the same for both a and b, for those endpoints. Now, what this theorem says is there's some number in the open interval between a and b, so there's some x value in between, such that the derivative of the function equals 0 for that value. Now, the first example is a constant function, and so the derivative is always 0, so that kind of satisfies this in a trivial sort of a way. If we look at the next example, we can see that we have a local maximum that has a horizontal tangent line, so the derivative there is equal to 0. So that is our value of c. For the third one, it actually happens twice. So we could call those values C1 and C2 if we wanted to. And then for the last one, it happens only once. The first one, we could pick any value in between A and B to be C. Basically, this just says that there is going to be a point somewhere on that graph that has a horizontal tangent line and that has the derivative equal to 0. And intuitively, I think that makes sense. If we ignore the constant function and we look at any function that's changing, if we start at a and the function is not constant, then it's going to either be increasing or decreasing, either at a or somewhere after a. And if it's increasing, eventually it needs to go back to decreasing again, so it can get back to the function value at b. And if it's decreasing, which is what's happening in our last example, eventually it has to go back up to increase to that same function value. And because the function is continuous and differentiable on that interval, we're not going to have things that cause problems, like sharp corners, which would require it to be not differentiable there. We're not going to have any sort of weird situation where we've got a discontinuity because we're told that it's continuous on that interval. So basically, if we have continuous on the closed interval, differentiable on the open interval, and the endpoints have the same function value, we know somewhere we're going to have a horizontal tangent line. We're going to have a derivative equal to 0. That's what Rolle's theorem says. Let's verify that this is true for an example. Let's consider a function, specifically f of x equals x squared minus 2x minus 3 on the interval from -1 to 3. Now, if we evaluate this function at -1 and 3, f of -1 is equal to -1 squared is 1, -2 times -1 is +2, and then -3. And when we combine those, we get 0. Similarly, f of 3 is going to be, we start with 9. 3 squared is 9, minus 6 minus 3, also equal to 0. So we've got a polynomial function, so we know it's continuous and differentiable everywhere. And we've got an interval where the function values are the same on the endpoints. So we know somewhere in this interval, there has to be an x value where if we differentiate the function, that derivative is going to be equal to 0. Let's actually find that value. To do that, we will take the derivative. So f prime of x is equal to 2x minus 2. And if we set that equal to 0, we can divide both sides by 2, giving us x minus 1 equals 0. And if we add 1 to both sides, that gives us x equals 1. So when x equals 1, the derivative is equal to 0. And so that is the value of c in that interval. C equals 1, that is the number that satisfies Rolle's theorem. This is just a small theorem, and it's leading up to what's next, a little bit bigger, the mean value theorem.